Welcome back to the classroom. My name is Mr. Wong. Today we're going to explain another exam question. This is going to be from the 2004 HSC physics paper, question 18 with 4 marks. This is going to go into answering module 5, inquiry question 2, which is all about circular motion. So let's get started. Firstly, we have a car with a mass of 800 kilograms, traveling at a constant speed of 7.5 meters per second on a roundabout so that it follows a circular path with a radius of 16 meters. I'm going to underline these numbers because potentially they might be key things to address in this question. So we have our motion here. Okay. Now don't forget, the reason why cars are able to move in a circular motion is due to a net force coming in, so to speak. So our net force, which is also our centripetal force, which is kind of why we say centripetal force is not a real force. It's a resultant force caused by other components. So let's kind of work out what could be the reason why we have a net force pointing inwards later on. Okay. A person observing this situation makes the following observation. There is no net force on the car because the speed is constant. And the friction between the tires and the road bounces the centripetal force acting on the car. Assess this statement. Let's highlight it. So we want to make a judgment here. Support your answer with an analysis of the horizontal forces acting on the car using numerical data provided. So there's 3 parts to this question, right? We're firstly trying to make a judgment. Do we agree or disagree with the statement? Support your answer with an analysis of the horizontal forces. So you could potentially draw a force vector diagram if you wanted. You could do an explanation as well if you wanted. And it says acting on the car using numerical data. So that also indicates that they would probably want us to do some calculations while we're at this. Okay, so let's get to it. I'm going to firstly talk about my judgment. What do I believe of this statement? Okay, write it out, make it really clear. With these assess type of questions, you know for sure if you make the correct judgment, you're going to get the mark. Okay, so we're going to say statement is not correct. Okay, so why is that not correct? Well, let's have a look. Let's try and look at our reasoning here. I already said at the start that the centripetal force is a resultant force. Okay, so this question or this statement where it says there's no net force, that's incorrect because the net force for an object to go in circular motion is the centripetal force, or it's the representation of the net force. So this part is incorrect. Because the speed is constant, well, the speed is constant for a uniform circular motion. The tangential velocity must be constant in order to give this nice little circle here. The friction between the tires and the road bounces the centripetal force. Okay, so here's the thing. The road has friction force on it. Okay, assuming we're not considering air resistance, obviously because it's not in the statement, so let's not get too fancy here. We can actually probably link what the net force is coming from. The net force is actually coming from the friction of the road as we are turning. So when the car's turning, all right, so it's changing position like that, it's because of the friction on the road moving against this change. Okay, so it's due to the friction moving against the car's rotation, hence why we get a resultant force that pulls it towards the center. Okay, so let's put that down. So reasoning 1, although there is a constant speed, so although speed is constant, remember, because the tangential direction is constantly changing, there is an acceleration, which means there is a net force. So although speed is constant, the tangential motion is changing, which means we get acceleration. If we have acceleration, then that means net force is bigger than 0. Okay? So our net force, in terms of magnitude at least, is bigger than 0, so it means it's not balanced. Okay? The second reasoning is the net force is contributed by the friction force as the car is turning. And it's this friction force that is our net force, or resultant force, which is also our centripetal force. Hence, the cause / resultant or resultant centripetal force. Remember, and I'll bang on about it as many times as possible, centripetal force is not a real force. It's a net resultant force caused by something else. In this case, it's caused by the rotation or the turning of the car around this circuit here. Okay? Last bit is to perform a calculation in numerical data provided above, so let's do that. So what I'll do is I'll just enlarge it back a bit so you can all see the numbers that are in front of me. Whoops. Okay, so we have 800, so we have mass is 800 kilograms. We have velocity, which is 7.5 meters per second. And then we have a radius of 16 meters. Okay. In this case, we are saying that the net force is equal to our centripetal force. Therefore, our centripetal force formula is mv squared over r. Make sure everything is in SI units beforehand. We have 800 kilograms times 7.5. I'll just do a bracket. You don't have to, but v squared over r. Okay, so let's do our calculation. And don't forget, this is a force, so it does have a vector. So it is exactly 2,812.5 newtons towards the center of our road here. So if I just move back up for our car in this position, this is our centripetal force. Just take some of these bits out. Okay. This is also equal to our net force, as we said. So in this case, it's equal to the net force, and it's contributed by the friction on the road. Okay. So there's that. I'm going to go back to the final calculations and explanations. Okay, so we are ending the video here. If you found this explanation useful in your understanding on centripetal force and uniform circular motion, hit that like button, subscribe if you haven't done so already, and I'll see you next time.